Okay, today we're going to look at homework 10. We're going to take a look at homework 10 just a little bit different than we would our normal lessons. So far, lessons 1 through 9, we've taken notes, done examples, made Edpuzzle videos, and then you've watched those and then gone to Math Excel and done your homework. This one's a little bit different because we don't really need a separate set of notes for homework 10 because we're still talking about domain and range and functions. So I decided that I would just show you some examples, like ones that you're going to see in your homework, and we'll work through a couple, and then you can watch this video along with the homework. You can do the homework without watching the video. It's really up to you, but this is just as a resource in case you're struggling on homework 10. Okay, so there are 16 problems in this homework. The first 3, I made a little note down here, 1 through 3, they're going to require you to go back to your vocabulary from lesson 9 and answer some questions and fill in the blanks. You are going to need to know the definition of relation, domain, range, and what makes a function a function. What values can be repeated, which ones can't, and so on. Then some of your problems have some graphs, and so we're just going to work through some of those problems. I tried to make my examples very similar to what you'll see in the homework so that it can help you. All right, so on number 4, you're going to be given a graph, and it's going to ask you for the shaded values, and I think I forgot to shade this little portion on the graph with red. So it's going to ask you for the shaded portion in interval notation. So if we look here, it starts at 2 and goes to 5. So we have closed circle and open circle. So we're going to start, when we're looking, we're on the x-axis, so we go from left to right. So we start at 2, so I'm going to go ahead and put a 2. That's a closed circle, and we have a bracket. So I'm going to put a bracket because it's closed, it's included. We separate the numbers with a comma, and we're going all the way to 5. Now, 5 has an open circle, and we finish it off with parentheses. So there's our interval notation. Now, it's asking if this is our domain or range. So we have to think, when we're talking horizontally, are we talking about X or Y? It might help to label your axes. This horizontal one is our X. X is our domain, okay? Number 5 is going to be very similar, except instead of looking at the x-axis, we're looking at the y. So when we're looking at the y-axis, we're going from bottom to top. We go smaller to larger values. So what's the lowest point we have on our graph? It's here at 1. That's a closed circle, so it's included, and we're going to use a bracket. Right? We use a comma to separate. And if you look at your graph this time, we have an arrow on the end. That means it goes on and on forever. So when we look at our y-axis, the shading goes on and on forever. So what do we use to denote forever? Infinity. And what do we always use with infinity? It's parentheses, because parentheses means it's not included. We don't know where this stops, so infinity always has parentheses. Now, it's going to ask you if we're looking at the domain or the range. We're looking at the y values. We know that the y values make up our range. Okay? Then 7 through 9, or I guess I missed question number 6 somehow. Oh, I apologize. Number 6 also goes back to vocabulary. That's what I was forgetting. So number 6 will ask you about some vocabulary. You're going to have to go back and think about functions and how many y-intercepts a function can have. So you need to remember, for question 6, I'll make a little note. The y-intercept is on the y-axis, and it's where x equals 0. Okay? So think about that. You might have to think about a function, think about your x values, if they can be repeated or not, and that should help you with number 6. Then 7 through 9, you're going to be given a relation. I apologize. You're given a relation, and you're going to have to pick out the domain, pick out the range, and then decide if it's a function or not. We did examples in lesson 9. So I'm not going to do a bunch of examples again because you already have those in lesson 9. So moving on to number 10. So questions 10 through 12 are very similar. So you're given the graph of a function, okay, and this is f of x, and it wants to know what f of 6 equals. So we know that 6 is really our x, or our input. So on the graph, we're going to find where x is positive 6. So here's where x is positive 6. Where's the graph at on positive 6? It's down here on negative 2. So I'm going to say f of 6 equals negative 2. Okay, and so that's the same thing you'll do on 11 and 12. Find the x value that it's telling you, and then see where that graph hits at that x value. Okay. Number 13 is the opposite. It tells you the y value, and it wants you to find the x. It wants you to find the input. So we're going to look at the graph. So let's just follow it and see where it hits positive 4 on the y. So this time we're looking at the y. So this one is at positive 6. This one's at positive 4. So this is the one we're looking at. We want the x value. So we're going to go straight down, and our x value is negative 2. So x equals negative 2. All right? Now, our last couple problems with graphs require you to do a little bit more. So here, 14 and 15 will look very similar to this. I've given you a function graph. First, we want the domain in interval notation. So we're going left to right, and we're looking at our x. So if this graph, this is the farthest point to the left, and where's it at? It's at negative 4. So I'm going to start with negative 4. Is that circle open or closed? It's open, so we use parentheses. Then we're going to go all the way to the right. So here's the point that's farthest to the right. And on the x-axis, where's that at? It's at 0. And is that open or closed? Closed. Okay, now we're going to do the range. So domain was left and right. Range is top to bottom. So we start at the bottom. What's the lowest point we have? It's negative 9. Is that open or closed? Closed. What's the highest point on the graph? 7. Is that open or closed? Open. Now it wants the x-intercept. So the x-intercept is where the graph hits the x-axis. So go along the x-axis and find the graph. It's here at negative 3, so your x-intercept is negative 3. If it wanted you to put that in an ordered pair, it would be negative 3, 0, but I don't think it asks for that. Your y-intercept is where this graph hits the y-axis, so we go along the y-axis, we find that point. It's down here at negative 9. We've used that in the range, okay? And again, if it asked you to do this one in an ordered pair, it would be 0, negative 9. So those are just helpful because you may need them later. For f of negative 2, it wants you to go where negative 2 is on the x-axis, and then go up or down to find the graph. So I'm going to have to go down, and it looks like right here is where I hit the graph. What number is that on the y-axis? It's negative 5. So f of 2 equals negative 5. Okay, so we had to do a few different parts there, but it's okay. It's all right. Just take it one step at a time. Remember, domain is left and right. Range is top or bottom to top. X-intercept is where it hits the x-axis. Y-intercept is where it hits the y-axis. And then when you're trying to find the value or the output value, sorry about that, there was an announcement. So on the last little part, when you're evaluating, just find that value on the x-axis and go to that graph and find the y value. Then last, Problem number 16 is a word problem. It's just like the word problem that you had in lesson 9. So you should already know how to do that. There's an example in lesson 9. So we'll make a little note. Okay. Now, I know that these problems have been a little bit different, but hopefully they haven't been too bad. I know this stuff is confusing. It would be a lot easier, I think, if we were in person and we could work on stuff and do some hands-on practice. But we are virtual, so just do your best, do the best you can. And if you need more examples or more help, please, please, please either hit that Ask My Instructor button on Math Excel, send me an email, do something to let me know you need me, because I would be happy to help you. Have a great day.